Hi, everyone. Yeah, I guess I'll just get started. Hopefully you all can see my screen and that's working out. So, yes, I'm Hope. I graduated last May from Macalester. I studied statistics and economics there, and I work now as a statistical assistant at Mathematica Policy Research in Cambridge, Mass. But around this time last year, I was doing some research on the survival analysis of recidivism risk assessment algorithms and wanted to share some of my findings with you. One note is that I collaborated on this project with someone named Ellie Weeks, and so she deserves half the credit for everything that I'm presenting here. Yeah. So to understand why I got into this project, I'll explain a little background. So I came across a story written by ProPublica last fall, and the story was called Machine Bias. And so I read this story, and I became really engrossed in the topic of how sort of recidivism risk assessment tools are used in the U.S. today to decide things like the length of sentences and parole and stuff like that. So I guess more generally, as someone who uses statistics, I'm really interested to use models to understand how members of our society are treated unequally under the current systems in place. And I figured by doing my own statistical analysis on this topic, I might kind of be able to understand more personally how our criminal justice system is serving justice unequally and maybe be able to raise some awareness around this issue. And then just a quick aside for any students who are in the audience right now. I, yeah, just I would really recommend working on projects that you care about if you can. I know that I kind of struggled with this as a student, trying to find data that felt like, it would relate to projects that were important to me. But, for selfish reasons, when I went into the job search last spring, it was really great to have worked on this project because I was so passionate about it, and I think that it made it a lot easier to write about it in resumes and sort of talk about it with people. So that's the end of my aside. Um, yeah, but first I'll quickly define some terms. So a recidivism risk assessment instrument is a lot of words, so I'll just refer to as an RAI here. They are used across the country to assess the likelihood that someone who has been convicted of a crime will commit another crime in the future. So right now, how it works is that when someone enters into the criminal justice system, they're given a risk assessment questionnaire that looks like something here to the right. And this survey gathers information on a defendant's criminal history, their social life, and lots of other things. So questions include things like, was one of your parents ever sent to jail? How often did you get in fights while at school? And stuff like that. So yeah, this picture is a real RAI, or like the survey component, called Compass, that's created by a private company called Northpoint. And then based on all of these questions, a score is assigned to each defendant based, And then with that score, once it's been calculated, it's used to inform decisions about who can be set free at different stages in the criminal justice system. So from things like assigning bond amounts to the length of sentence, judges sometimes have this score in hand when deciding these things. So there are sort of potential pros and cons to an RAI. A well-functioning one is a really appealing concept because for a long time, key decisions in the legal process, from things like pretrial release to the length of sentence and parole, have been in the hands of humans who are guided by instincts and personal biases. And so if an RAI could accurately predict which defendants are more likely to commit new crimes, then the criminal justice system could be fairer and more selective about who's incarcerated and for how long. But the trick, of course, is to make sure that the technology we're entrusting to make these decisions is producing accurate predictions, right? So if the risk score is inaccurate in one direction, then a dangerous criminal could go free earlier than they should. But if it's if it's inaccurate in another direction, then someone could unfairly receive a harsher sentence or wait longer for parole than they really should be. And so in the past year, some evidence and stories have emerged showing that one of the most widely used RAIs, called COMPASS, is overestimating the risk of reoffense for defendants of color and underestimating the risk of reoffense for white defendants. And so in this project, I wanted to use the models that I was learning in survival analysis to sort of perhaps replicate these findings or figure out something new for myself. And luckily, survival analysis is a really good tool towards understanding the predictive accuracy. So yeah. So the data that I used for this project consisted of about 7,000 individuals who were convicted and assigned a COMPASS score in 2013 and 14 from Broward County, Florida. And I actually found this data set through a resource called Data is Plural. And if you're a student and looking for project data, I would definitely check out that database. And so, yeah, the data was already scraped and compiled. This sentencing and RAI information was made publicly available through the researchers at ProPublica, which was super nice for me. Yeah, and then we cut off the time, my collaborator and I cut off the time that we were taking in data in April 2016. So, yep. If you're unfamiliar with what survival analysis is, don't worry. I don't think at many undergraduate institutions there's a whole class on survival analysis, but lucky for me there was at Macalester. So survival analysis is generally defined as a set of methods for analyzing data where the outcome variable is the time until the occurrence of an event of interest. So it's used a lot in clinical trials to understand how a certain drug works among a sample of patients. But in the context of this research that I was working on, the outcome of interest, or the metric of survival, was the time until recidivism. And so put differently, it's the survival time here is the length of time until an individual in our data set returns to jail, if they ever do. If someone is never reconvicted for another crime, then they're what's known as censored. So this dotted line in the picture shows our cutoff date, which is April 2016. So if the blue line goes past the gray line, then we're not sure if the person ever did recommit a crime or not. And so that's sort of something special about survival analysis, is that we have to treat these individuals. We don't just throw them out of our data, but treat them slightly differently, since we don't know their exact time until recidivism. Yeah. And so for me, the process of working in a research project is usually sort of an iterative one between getting the data, cleaning it. Hopefully that's not iterative, that happens at the beginning, and then plotting the data to understand the questions that I want to answer, and then going on to modeling. So this plot here shows the simple proportions of how individuals in each racial group were classified into different risk types of the RAI. So the risk score is on a scale of 0 to 10, but I clumped it into categories just to be able to visualize this better. And so from this figure, you can notice that a high proportion of African Americans are classified as high risk relative to other racial groups, because this block is larger. But this picture doesn't tell us any information about whether or not the score assigned to individuals was reflective of the actual time to recidivate. So to do so, we specified a Cox proportional hazards model. And I'm not going to go into theoretical details of how that model works, but if you're interested to learn more, I would definitely recommend you keep taking stats, and maybe check out something like the Summer Institute in Biostatistics. So the model itself is the independent variable is the time to recidivate, so the survival time. And then we modeled it on the race of each individual, their COMPASS score, the degree of the crime, which is felony or misdemeanor, and then an interaction term between race and COMPASS score. And this interaction term is going to sort of be key in answering the research question. So if the coefficients on the interaction term are significant or statistically significant and non-zero, then we can conclude that the predictive accuracy of the risk score is not uniform across racial groups. So yeah, onto the results a little bit. So these results are interpreted in terms of hazard ratios. And the important thing to pay attention to with a hazard ratio is whether it's above or below 1. So a hazard ratio of 1 means that there's no difference in the time to recidivism between the two groups under comparison. Whereas a hazard ratio bigger than 1 means that a covariate is associated with a faster time until recidivism. So once we ran this model in R, we got coefficient estimates and calculated their corresponding hazard ratios. And so you can see in this first line that the hazard ratio on risk score is greater than 1, which makes intuitive sense. It means that an increase in the risk score is associated with shorter time until recidivism. And so on some baseline level, these RAIs are functioning. And the hazard ratio on misdemeanor, you can see in this, let's see, it's like the 2, 3, 4, fifth one down is less than 1, which also makes sense. It means that having committed a misdemeanor rather than a felony, which is the reference category, is associated with longer time until recidivism. And then moving on to these interaction terms, the reference category here is white, and we notice that some of the hazard ratios on the interaction terms are above 1 and some are below 1, which indicates that the effect of the risk score is different for convicted offenders of different races. And specifically, we noticed that with a 1-unit increase in the COMPASS score, the hazard of recidivism is, let's see, like 0.94 times lower for Hispanics than white convicted offenders. And about the same metric is true for African Americans relative to whites. There's a hazard ratio lower than 1. And so we can interpret these interaction terms to mean that African Americans and Hispanics tend to have higher COMPASS scores coupled with lower recidivism rates relative to Caucasians. So meanwhile, high-risk Caucasians, or like I guess what these interaction terms sort of suggest is that high-risk Caucasians are receiving lower risk scores relative to their high-risk counterparts in other racial groups. And so that's a pretty important finding. I think, yeah, it's hard for, it's always, I think, in statistics hard to grapple with interaction terms, but here we're able to get some pretty important information out of them. So why is this important? The COMPASS tool, the one that we studied in this project, is the most widely used risk assessment instrument in the whole country. And it's used by judges in Florida, Wisconsin, New York, and some other states. And so what seems to be happening is that judges are receiving these risk scores thinking that they're an objective metric because they're coming from you know, these tools that are accurately predicting an individual's chance of recidivism, but we found through our analysis that there's some racial difference in the predictive accuracy. And so I think recognizing the flaws in these risk scores is an important first step to changing how they're relied upon in the criminal justice system. And doing my own analysis of it was pretty exciting. So that's the explanation. I want to thank you guys for listening, and also to my professor of survival analysis, Victor, who taught me everything I know about survival and also most of what I know about statistics. So thanks. That's all I have. I can take questions. Maybe there's like 1 minute left.
Yeah, Hope, I think there is one question. I think the question is, one extreme that could be taken is that we should do away with statistical risk assessments, just because with how COMPASS is working, perhaps it's biased. How would you reply to this?
Yeah, I think that's a good question. You know, I think that risk assessment tools across the board do have potential to be really helpful. I just saw an email this morning about sort of using machine learning in healthcare to flag when a patient is at most risk for, you know, some X medical issue. And I've heard a lot in statistics that the term garbage in, garbage out, meaning that if the data that you're inputting into into any risk assessment tool is biased in some way, then the things that are coming out of the model or the risk assessment tool are also not going to be very helpful. And so I think it's the same thing here. It's just a matter of understanding how these risk scores are actually calculated, because that's proprietary information since private companies make these things. And so it's just a matter of like sort of unwinding how they're created, and then I think that they could potentially be helpful. Yeah.
Great. Thank you very much, Hope. It was a really interesting talk.